Good afternoon all. I'm in the garden today looking at my two quadcopters. I've got the HiSky X4, which is a brilliant little training quad. I've learned how to fly pretty much using that. I don't fly very well. I can't yet fly with the quad facing towards me. I can only fly it with it facing away, but I'm sure I'll learn that over time. I've also got the Cheerson, although this appears to be called an Intrude. It's basically a Cheerson. Is it a CH10 or something like that? Another brilliant little quad for learning. This one's great because you can fly it indoors. It's so tiny and it's got this protective frame, so it doesn't matter if you knock it into the walls. But I'm quite keen to move on to the next level now, something a bit bigger. So I was very pleased when Banggood offered to send me this. And this is a HiSky HMX280 quad. I'll get my tape measure in a minute and we'll see how big it is, but it's considerably bigger than the Hubsan. You can see that here are the motors on the corners. There's the Hubsan. I'll take it out of the box in a minute. We'll just quickly go through what it's got. Now, Banggood have sent this to me for review, so I'm going to put it on my reviews channel, but I don't yet have any sort of procedures for reviewing quads, and I did want to kind of get to know this thing first. So let's go through all the bits that are in the box. So the quad itself measures 280 millimeters across the diagonals between the motors, so I'm just wondering whether that's why it's called a 280. You can see it's a fair bit bigger than the Hubsan and certainly the Cheerson, so it's a substantial thing. And the kit does include everything you need to fly, propellers, spare propellers. Here's the battery. This is a 3-cell, 11.1 volt, 1350 milliamp hours with main JST power connector and a 3-cell 4-wire balanced charge connector. You also get a balanced charger. It's an interesting little thing. I mean, you can see that this has been built to a price point. It's mains powered. Now that's slightly inconvenient because if you're flying in the garden, you've got to keep running back into the house to charge the battery. If you're flying in a field away from home, well then this is quite impractical unless you've got some sort of inverter in your car. But what is interesting is that this charges the battery not through the main power lead, but through the balanced charging lead. So it plugs in like this, just on the balanced charging lead, and these connectors are quite chunky, so you can put, I think this puts out, yes, 1200 milliamps, so 1.2 amps through the balanced charging lead. The main power lead is not used when charging, and in fact inside this thing, I'll open it up in fact, it's just got 3 completely independent mains powered charge circuits. So this is what's inside. It's just 3 completely independent mains powered circuits, and you just simply plug the battery in and then wait for the 3 LEDs to change from red to green, and they do that in sequence, and then when all 3 are green, you know that the battery is charged. Now it's meant to take about 1 hour, 1200 milliamps output from this 1350 battery, but it does seem to take quite a bit longer than that. I'm not sure whether this is actually putting out a bit less current than it says. Oh, that's quite interesting. Lots of chips on the back, so presumably it's doing the full CC or CCCV charge profile. Looks like it probably is. It works, and you know, it does the job, and if you don't have a balanced charger, then this is what you use. The mains cable supplied with the charger has an American 2-pin plug, and the adapter for UK use is not to be used. But it's not a major problem because the charger does have this removable plug. You can very easily just find your own lead with the proper UK mains plug on it. But I very quickly decided that I'd be better off using this Turnigy balanced charger. So I'm doing a slightly higher current charge than the battery actually says, 1.5 amps, but I think that's fine. What are we at? 11.58, and the end voltage is 12.6, so a little way to go. I'll just leave that charging. That's the Turnigy connected to a 12 volt lead acid battery, which is in turn being charged from one of the solar panels on my new solar panel frame. These two things are the feet. They screw onto the underside of this. I'll do that in a moment. And then the other thing supplied, of course, is the transmitter. Now, I'm a complete newbie to radio control equipment. I can see that this is a 2.4 gig controller. I really didn't know what all these switches did when I first got it. There's an idle switch, there's a throttle hold switch, which actually seems to just cut the throttle off. There's a gyro sensitivity switch, which the manual does cover, and then there's something labelled AER. Now I assume that's ailerons, elevator, rudder, or DR. It's all a bit confusing actually for the newcomer, but I found out that if you just push all the switches away from you, it's fine. And in fact, if you switch the thing on with a switch in the wrong position, then it just says something's wrong, and you put it right, and oh, now the throttle stick is not in its fully down position. So until you get all the settings right, it just beeps at you, which is quite good because it means that you can't really start this thing up in the wrong mode. Now, there's a little sort of menu system here. Quite interestingly, it tells you the battery voltage, which is good. So you got function, sys, everything is very heavily abbreviated. Fun, sys, there's a flight timer there, which I suppose could be handy to make sure you don't over discharge the battery, but there is a low battery warning of sorts. So you can go in here and you can modify lots of settings, things like reversing the controls, changing the sensitivity of the controls, all that sort of stuff. But I found that you didn't have to do really any of that. It flies pretty much right from out of the box. So now we fit the landing gear. This tiny supplied screwdriver is just about big enough to do up the screws that hold the landing gear on, but this screwdriver is mainly meant for putting into the prop, these top screws for the motors, and tightening them up, but I'll come to that in a moment. And then on the second skid, you have to thread this antenna through and into the foot there, so I'll do that now. So that's the antenna pushed into these little gaps in the plastic and mounted in the foot there. Now, just a quick look at the underside here. There are a number of ports, including a USB port here and some other ports around this side. Now, there's not much in the manual about this, but there is a little bit. Just this diagram that says that A is a USB port, B is a DSMX/2 satellite receiver port, no idea what that is, an 11.1 volt battery port, and a gimbal control port. And there are screw holes on the bottom here, so this looks like it's designed to take an FPV camera on a gimbal and has gimbal outputs from the control board, which is a CC3D. On the back of the manual, you can see here the openpilot.org logo, and that's the open source group that that produces the CC3D board, or at least that's what I think is the case. So to some extent this is an open source product. Certainly in a later video I'd like to connect USB to this port and see if we can take a look at the settings in the CC3D flight controller board and maybe even fine-tune some of them. Right, now it's time to put the props on. Now the two orange props go at the front, the two black props go at the back, but the props are different. One is a clockwise prop, one is a counterclockwise prop, and the manual does give information on how to get these props on. Also, these screws that fit on the motors, two of them are left-hand thread and two of them are right-hand thread. So using this diagram in the manual, it shows you how to identify the props and fit them on, and then you use this screwdriver to tighten the props. Of course, the counterclockwise ones tighten counterclockwise, and the clockwise props tighten the normal way. Now you can see I fitted two elastic bands onto here, and that's to hold the battery in, because unfortunately I've already broken the door. These pegs are quite small and one of them's broken off, and this just doesn't stay on now. It if you hit anything or the ground, it just flies off and the battery flies out. So I'm using these elastic bands. So now it's time to put the battery in. Let's see if it's charged. No, it's not. The cells are only at 3.95 volts, but they are all at least the same, 3.95 across all three cells. That one's at 396 now, so it does look reasonably well balanced, but I will wait for it to fully charge. Right, the batteries are all closing in on 4.2 volts, they're all at 4.17. This is where the Turnigy will now start winding the current down. So for a nominal 1.5 amp charge, the current will now drift all the way down to 0.15 amps. So we'll probably get to between 0.1 and 0.2 amps, and then this thing will say that the charging of the battery is finished. Right, the battery is charged, so I'm going to put that in the model now, but I'm not supposed to connect it to the quad with the transmitter switched off. It is apparently radio control protocol that you put the transmitter on before you connect the battery to the quad. Now there is a binding process, and there's also a motor disarm process. It probably wouldn't be a disaster if you did it the other way around, but this is convention. I suppose it stops little Johnny next door from using his radio control to cut your fingers off immediately after you've put the battery in the quad. And this thing does scare me a little bit, so I've taken to connecting the battery up to the quad with it upside down. So if the propellers did start up, they're kind of on the grass, and the thing would be flying itself into the grass rather than at me. But let's do this properly. Let's turn the transmitter on, and now I'm going to attach the battery connector. I can't do that without two hands, so I'll do that off camera. Right, I've just gone and got a tripod, so let's see if I can capture this on camera. Turn the transmitter on, attach the battery connector. Now, it's supposed to bind, but I really can't fathom this binding process at all. I've got rapid flashing here. We're supposed to bring the right-hand stick to bottom left. Perhaps that is the binding process. But this flashing is just incomprehensible. I don't know what's going on there. But I'll flip it over, and I don't know whether you heard that tick, but this thing sort of just randomly glitches, and the props just click and turn ever so slightly, so I'm not sure what that is either. Well, it does seem to be bound now, because I can raise the throttle on the props. Just slight movement on the throttle turns the props. Let me see if I can do the disabling thing. Bottom right. Yeah, that seems to have switched it off. Bottom left. That seems to have switched it on, but as I say, the green lights are fairly incomprehensible. Okay, let's try a quick flight. I'm not sure if this is going to be on camera or off camera, but let's give it a go. Yikes! Right, let's give this another try. I'm going to stand a bit further back this time. Oh, it seems to have unbound now. Well, now it's just not controlling it at all, so I don't know what's going on. I go to... oh. So the binding process is very confusing. I haven't got to grips with it at all yet. It's still glitching as well. Let's get a close-up of that. So the transmitter's on. Let's put that there. It's a bit rear heavy, this quad, so it tends to tip over backwards. Let me just see if I can capture this glitching. There, you just saw the right front propeller twitch a bit. Now, I'm sure it's not a major problem, but it is a bit odd, and I don't know whether anyone's ever had this problem on the CC3D controller before, but it's just a little unnerving. But despite everything I've said that might sound a tad negative, it does fly remarkably well. You can get it to bind. It's very stable. The PIDs, I think, are set very gentle. It's good for a new flyer. Now my throttle is barely off the end stop, the bottom end stop that is. So it would appear that this thing has a massive amount of power, as you can see from that little hop. So it should be more than capable of holding a camera and a gimbal or other forms of payload. It does seem to be quite a powerful machine. Now, the flight time is reasonably long. It flies for around 12 minutes, something like that. And if you fly it gently, I think you can get a bit more than that out of it if you're just hovering it in front of you, like what I tend to do, because there isn't a lot of space in this garden. The low battery warning is the red LED inside this white cover, but as you can see, it's quite difficult to see, very difficult to see if it's in bright sunlight, in fact impossible. So, but I have noticed that it was flashing at one point, brought the thing down and put the battery back on the charger, and it said that it was about at its storage charge level, so nowhere near empty. So I think the warning lights flash quite early, and that's just so that you can bring it down in plenty of time. But when they're flashing, you've got plenty more control. And the manual says that what ultimately protects the battery is that the thing just drops out of the sky. Not at a plummet, I hope, but certainly the props do seem to get quite weak once the voltage of the battery drops fairly low. So I've just flown the remaining charge in the battery, and it flew for what seemed like ages. I suppose I'm used to the Hubsan flying for only about 5 minutes, whereas this thing flies for more like 15. It really does give you a chance to experiment and be a bit more courageous with your flying. I'm really starting to like this quad, actually. You do have to fly it a little bit further away from your face. I tended to experiment with the quad very close up to me, the Hubsan that was. You wouldn't want to do that with that big one because it would cut your face off. So on Banggood's website, this is the item. It's the HiSky HMX280 5-channel 2.4 gigs 6-axis gyro RC quadcopter with a CC3D flight controller. It's showing currently as £110. Let's just change that to dollars. So that's $166.99. Now I'm just going to scroll down because there is some useful information here, videos and lots of stills of this particular quadcopter, but there's more information down the bottom of this page. Right, so further down we've got note it's not a waterproof quadcopter. That's mainly because there are lots of photos above of it flying above water. There is a downloadable user manual here, some information here. Now there's a couple of notes, not waterproof, and it says the CC3D flight controller and ESCs, electronic speed controllers, are customized, different from other products on the market. If you want to use another flight controller, you have to refit its connectors and use another ESC. And I will provide a link to this quadcopter in the description. But now, since it's such a nice day outside, I'm going to go back out and do some more flying. Cheerio.